Okay guys, let's look at more challenging questions on integration rules. So we want to integrate this. You can all see that there are four terms. So under normal circumstances, we need our integration sign four times. So those are my integral signs four times. But now to transfer the terms here, we need a lot of level 2 simplification here. So let's start with the first one. The first one there is the root of x all that square. So you must open that bracket and figure out what is happening there. So if I open the bracket, it means I'll get 2 square, because that square you see is outside, it belongs to everyone inside. Then I also get root x square. So the 2 square gives me a 4, and we know that the square root will be taken care of by the square. So this is 4x. So actually, this item is the same thing as 4x. So when I'm transferring it to my problem, 4 is a constant, it will go out, x dx will stay. Then for the other one, you see that 2 goes out, and 1 over x stays in, so that we use formula 23 there. Then, this is a very interesting one. You see, this is 5t. In integration, you have to understand the reason why the n with an x. When the n with an x, they tell you that anything you see in there that is not x is a constant, and all constant step out. So here the whole of 5t is going out, we're only left with dx. Then in the last one, again, there is some level 2 work to be done there. It's obvious that 1 over 2 is the constant that will go out. I'm taking it out because it has nothing to do with the root sign. So I'll just simplify the root sign. 1 over the cube root of x will be 1 over x to the power 1 over 3. And we've earlier seen with other videos that we don't allow x at the denominator except the power is 1, so that we use formula 23 to get to lim. So if x to the power there is not 1, it goes up to the x to the power negative 1 over 5. So that is what we get there. So that is the first part of our problem. Then we can go through and use different formulas to integrate each term. So the first one is formula 20, which if you are integrating, you get x squared over 2. The second one is formula 23. Each time you are integrating 1 over x, your answer will be x. The third one, you are just integrating dx. So each time you integrate dx, you get an x. Then for the last one, we'll get back to formula 20, where we'll take negative 1 over 3, we'll add 1 to it. It will give us 2 over 3. Then we'll divide by 2 over 3, then plus c. So we now go to the simplification part. 4 divided by 2 is 2. Then this is 2, then x doesn't need simplification. 5tx does not need simplification. So with this one, you just need your calculator to take a half divided by 2/3. If I do it in my own simple way, it's a half divided by 2/3, which is the same thing as a half times 3 over 2. So you see that you get 3 over 4. But if you take your calculator and do it straight away, a half divided by 2/3 will give you 3 over 4. And then the x does not have a negative, so it stays up. So when I'm writing my x, I put this root sign. The denominator goes out there, the numerator follows the x inside, and that is your problem. So this is our rough page, and that is how your final solution should look like. You must remember that if your original question had a root, the answer must get a root. If you don't do that, then you are not yet forced to it. So thank you for that one. You can now move to the next challenging problem. So again, this one is 4 terms. So according to my integration rules, I need the integral sign 4 times. So I'm putting my integral sign 4 times. Then I have to start transferring my terms. This one is straightforward. The constant is 15 outside, the variable inside. Then when you go here, the constant has got nothing to do with the root. So my constant is negative 3 over 2. But with the root sign, we need a bit of rough work. So the root sign looks like that. We can integrate the third form. So we will simplify it with x to the power 1 over 2. And since this is not 1, the x goes up. So we look at it like that. So we have x to the power as a constant, it goes out, in we get e to the power 2x dx. Then this one, you see the little trick. The little trick there, it has a square. So that square again belongs to everyone inside. So if you have it like that, it means I will square the 2 and I will square the sec. And with trig functions, guys, you have to be careful. The algebra does not affect the angle. Trigonometry has different rules for angles, so this squaring must not affect 3x. That's why we always put it on the C, then you get your 3x. So 2 squared becomes a 4. So it shows that our constant here is a 4, then our variable is a sec squared 3x. So now again, each term has got its formula. The first term is formula 20, so we get 15 x cubed over 3 minus negative 3 over 2x. If you add 1 there, you will get the power half divided by the half. Then this is formula 24 on level 4 formula sheet, where our k is 2, so we get e to the power kx divided by k, then k is 2. Then the last one is formula 27, our k is 3, where we get our tan kx, that's tan 3x over 3 plus c. So if we now do our simplification, 15 over 3 is 5x cubed, then 2 negatives will become positive. Again, with this one, you simply use your calculator to help you to take 3 over 2 divided by half. If I want to do it the primary school way, I'll write it like this: 3 over 2 divided by half, which will be saying 3 over 2 times 2 over 1. You have to invert the second fraction. You see the 2's go, you're left with a 3. So 2 negatives there, then you have a 3. That becomes root x. 4 over 2 gives us a 2e to the power 2x, and 4 over 3 remains 4 over 3 times 3x plus c. So guys, this is all about that, and that is how you do your integration rules for problems that look like that. So thank you very much. I hope this helps.